Hello, guys. First thing, I want to apologize because I won't be able to be there, but as you may notice from my voice, I'm still a bit sick, so I'm not gonna take the risk to keep spreading whatever virus I have. So I'm just going to continue with what we started last time. We started section 6.1, but we just did half of the worksheet. I'm just going to explain the rest of this lesson. This this video is going to be quite long, so feel free to pause it anytime you feel like you need to have a break or rewind it just to see if there is anything that you don't understand. I'm going to try to explain it step by step, and hopefully this will be now enough for you to start working on your Big Ideas Math Assignment 6.1, which is already posted on Big Ideas. So we're gonna start with exercises 10 and 11, and our task will be graphing the functions you see right here. The first one is 4 raised to the x minus 2, and the second one is the one we have here, 4 times a half raised to the x plus 1 exponent. So just as we mentioned last time, in order to graph an exponential function, we will need to make a table, and we will have at least 4 values. We are going to evaluate the function in these 4 values: -1, 0, 1, and 2. Okay, so let's begin with exercise 10. So starting, and if you please take a look at your right, I'm going to solve it here because I have some room. We're going to evaluate the function at -1. So we just need to substitute it here and then solve as needed. Because of order of operations, we need to solve this first. Remember that this takes down the 4 like this, and -2. This is equal to -7/4. Once you verify this operation, then we write it down here, -7/4, and now we're going to keep going with the other 3 values. Okay, so let me erase this, and we just keep going as usual. Hopefully you now are trying to do it on your own. Now we're going to evaluate the function when x is 0. So this is 4 raised to the 0 power minus 2. This whole thing is 1 minus 2, and that equals -1. So we write it here, and we continue with the other 2 values. So I'm going to do it as quick as possible because it seems like you now get it. So f(1) is 4 raised to the power of 1 minus 2. This is 4 minus 2 equals 2. We write it here, and then finally, let's do it with 2. And here we are. F evaluated at 2 is 4 squared minus 2. 4 squared is 4 times 4, 16. Minus 2 is 14, and we write it down here. Okay. Oh, I'm sorry. It seems like there was an issue here, but no. 14. So now we're going to locate these 4 points in this coordinate plane we have here on your left. So I'm going to draw the axis. Sorry, because sometimes I do not make straight lines, but anyway. So we're gonna start with these values somewhere over here, right? So this is x, this is y. Let's begin with the first point. I'm going to do this in red. When x is -1, you know what? I'm going to make it this way. This is probably, I'm going to use black. The intervals are better be like 2, 4, 6, 8, and so on. You always take a look at this, the highest value, okay? So this is going to be -2, -4, and so on. Now we can do it. Let's begin with -1. -7/4 is somewhere over here. All right. With 0, we've got a -1, which is somewhere over here. And then when x is 1, y is 2, And when x is 2, y is 14, somewhere over here. I hope you can see now the shape of that curve, exponential curve, so I can do something like this. Not the best, but this is one of the curves that we already saw. This is it, okay? I want you to notice something. This -2 is some sort of ground or floor that our curve will never touch. Keep this in mind for future reference. But we're done. Now we need to describe the domain and range for exercise 10, this function. Remember the domain, and let me do it right here. Remember that the domain is the set of all, oh, wait a minute, it's like, okay, domain. The domain is the set of x values the function uses. As you can see, and I'm going to use red this time, the function keeps going to the left, and as it goes up, it will keep going to the right. It means that it's going to use up all the number line, the horizontal number line. It means that in terms of domain, let me use red, the domain of this function is all real numbers. Or we can represent it as an interval that starts at -infinity and ends at infinity, meaning that I am covering all the real numbers. Now, if we want to talk about the range, now remember the range is the set of the y values or the outputs. Now it's a little bit different because as you can see, and as I told you, this graph, the blue one, starts at the lowest value being -2. So the y values cannot go beyond that. Even if we pay more attention, you will see that -2 is not even a number in here. But anyway, this is the lowest value. But as you can notice, this function is going to keep going up to higher and higher y values. So there's no limit, so I can say that it will reach to infinity. And thus we have the description of the domain and the range. Now I'm going to do it for exercise 11. If you want, pause the video, take a break, I don't know, do something, but make sure that you come back soon because now I'm going to do exercise number 11. All right? So here we go. Exercise number 11. As we mentioned before, we are going to do our table with x and y values. We already mentioned that we're going to use -1, 0, 1, and 2. Okay, let's erase this. And let's start completing our table for the outputs or the y values. Beginning with f of -1. Here on your right, we have 4 multiplying 1/2, 1 plus 1. So f of -1 is 4 raised to the 1/2, times 1/2 raised to squared. So if you solve this in your calculators, 1/2 squared, we have to solve it first, remember, is 1/4. And 4 multiplied by 1/4 is 1. So we have our first value. Remember, if there is something you don't understand and then you notice that I am going pretty quickly, you can pause this anytime. This is the advantage of doing this on video. All right, you can rewind it, go back and check and have me talk again and so on. All right, now let's do f of 0. F evaluated at 0. This is 4 times 1/2 raised to the 0 plus 1. So this is 4, 1/2 raised to the power of 1, which is the same 1/2. And 4 times 1/2 is a 2. Got it. Let's erase and keep going. Now you know the drill, right? So we have f of 1 is 4 times 1/2 raised 1 plus 1. And you know what? I think I made a mistake. So if you go back, you're going to help me correct this, okay? Because in the first, we made a mistake here, okay? We're going to get back to it soon. So this is where we have our 4 times 1/4, which is 1. I just noticed that I made a mistake, right? Because if we had -1 right here, this was -1, and this should be a 0, right? And remember that anything raised to the 0 power is, remember, 1. And 4 times 1 is 4, so I'm going to write it right here, okay? 4 to 1. And finally, we're doing our last one. When f is 2. Sorry, when x is 2. We are evaluating when x is 2. So let's get to it. F of 2 equals 4 times 1/2 raised to the 2 plus 1. This is 4 times 1/2 cubed. And this is 4. If you do this with your calculator, this is gonna be 1/8, which is gonna be 1/2. This multiplication, okay? So 1/2 or 0.5, as you wish. The lowest value being 0.5 for the y's, and the highest one is gonna be a 4. So we're good. We can probably do this right here. The x-axis, the y-axis somewhere over here. And now we're going to use blue to locate our points. When it's -1, we got 4. Is that it? So each square is a unit, right? No big deal. When x is 0, y is 2, so it's somewhere over here. When x is 1, y is 1, so we got it here. And when x is 2, we got 1/2, somewhere over here. Now you see the shape, right? Let's use green for this curve. What? I'm sorry, I'm not great at this. Okay, this is our curve. Awesome. Now let's describe domain and range. Let's begin with the domain. And let me tell you a secret. The domain for any of these exponential functions is always all real numbers, because as you can see, we're always using, can you see that this keeps going up but keeps going to the left? So it uses up all the values to the left, but also uses up all the values to the right. So all real. So you do -infinity to infinity. That's it. Okay, now let's do the range. Can you see that it has some sort of floor or lowest value that it will never touch? All right. Did you get it now? Well, perfect. It's this one over here. Can you see that it never... Oh, sorry. I am erasing. Should not be like this, but our curve will never touch the x-axis. So it means that the lowest value for the range is 0. But as you can notice, this thing will keep going up. So it goes to infinity. That's the range. And that's it. Exercise 11. Again, if you want to pause it, feel free to do it while I erase. And then I'm going to start solving exercise number 12 with new instructions, okay? I don't know, take a break, go to the bathroom, feel free to do it. Well, although you are at school, right? Well, anyway, you can do it. Just ask the sub respectfully and make sure that you don't take a lot of time, right? Exercise 12 and 13, we need to write an exponential function. An exponential function represented by the table or the graph. So using the values we see here, we need to make sure we write an exponential function just like the one that I'm writing here. Keep in mind that a is what we call the initial value. And that initial value happens when x is 0. This is the clue, important one. And b is what we could call growth factor, although usually we use it when the curve goes up, because if the curves go down, we call it decay factor, okay? But I can say, for example, just to save some time, that this is a negative growth if it goes down. All right, so don't worry about that. But anyway, growth factor, just for your information. Growth factor. Okay, so let's see how we identify the initial value and the growth factor in either the table or the graph. When you have a table, can you see that the initial value being 0 is right here? So the y value in this case is 3. So we already found that initial value, a equals 3. Now, if you want to know what b is, let's make sure of something. Can you see that the x values are increasing by 1? So now I am going to take a look at what happens as the y values increase. 3 to get to 18, we multiply by 6. 18 to 108 times 6, and so on. This little friend, my dear friends, is what we call our growth factor. Okay, so it means that we have already found what b is, which is 6. Once you do that, you can now write the equation of that exponential function. As you can see, 3 multiplied by 6 raised to the x value. That's how we do it. All right? All right, keep that in mind. Well, now, it seems like I lost the whole thing. Is it going to be here? Oh, come on. All right, it's right here. Okay. Now I'm going to erase this whole thing. You already know what the answer for this is. All right, this is the answer for number 12. Now let's take a look and solve number 13. Again, if there was something missing in here, just pause it, go back. When you are trying to find out the equation of an exponential function using a graph, we can go from a graph and convert it into a table. Can you see the values here? All right, let's do this. So x and f of x. When x is negative 1.5, y is negative 4. When x is negative 1, y is negative 2. Are you getting this? Look at this one. We got it here. When it's negative 0.5, the y value is negative 1. And finally, when x is 0, the y value is negative 0.5. All right, there are a couple of things that we need to notice here. Remember, we need to find out what a is and what b is. All right? Seems like a is really easy to find. Can you see? Where x is 0, we found the y value. So I'm going to keep writing on the right. So a is negative 1/2. Let me use fractions this time. Now I want you to notice something. Now we're going to take a look at b. Can you see that we're increasing by 0.5? Be careful. Make sure that you go from one unit to another unit. So can you see the difference between negative 1 and 0 is 1 unit? That's what we need to look. From negative 2 to negative 0.5, what happened? Remember, we always think in terms of multiplications. This is times 1 over 4. So that's our b, okay? b is 1 over 4, and we have what we need. Our equation, which I'm going to write in red, is y equals 1/2 times, negative 1/2 times 1/4 raised to the x value. And that's it. That's the solution for number 13. Now, we're almost done, guys. Number 14. Again, take a break. I know this is not an easy thing. Just make sure you have a little break and then get back and completely focused for the last one, which is honestly really easy. Look at this. We're going to zoom in a little bit. Okay, we're going to graph the function and then graph this other function, and we're going to compare. What do we need to compare? We're going to see what happens with the y-intercept. We're going to see what happens with the domain and what happens with the range once we make this change, this little change. Can you see that this is 2 raised to the x, and this one is including a +3 right here? So as usual, we need to make a table and then graph those points. Let's begin with this one. X and Y, so we have -1, 0, 1, and 2. So f of -1 is 2 raised to the -1 is 1/2. So 1/2. F to the 0 power, sorry because my writing is awful, but what can I say? All right, so this is 2 raised to the 0 power, right? Which is 1. Let's write it here. F to the evaluated at 1 is 2 raised to the power of 1, which is 2. And finally, f of 2. This is terrible, right? This f looks awful. This is 2 squared equals 4, so we got it right here. 4. So, and you see that the lowest value is -1/2, the highest one is 4. So, let's do this. Let's use our x-axis here and the y-axis right here. You think so? Oh, you know what? Well, yeah, no problem, no problem. We can see that we're going to do this in red. When x is -1, y is -1/2, so it's somewhere over here. When x is 0, y is 1, so it's right here. When x is 1, y is 2. And when x is 2, y is 4. All right? Let's see if our palette comes back. It's right here. Well, I want you to take a look at this and see that... oh, my bad. Guys, I made a mistake and I want you to notice what the mistake was. This was 1/2 and not -1/2. I need to correct this. Which means that this point doesn't go there, but right here. And it makes sense because there is nothing next to it, and you will see that the lowest value this graph may take is a 0. Boom, something like this, all right? Okay, if we do the second one, which includes that +3, then let's see what happens. But I want you to notice something, all right? I'm going to keep the first table where we had -1, 0, 1, and 2. We had 1/2, we had 1, we had 2, we had 4, and we can even do 3. That gets to 8, right? But now let's do this, which goes g of -1 is 2 raised to the -1 plus 3. This is 1/2 plus 3. This is 7/2. G of 0 is 2 raised to the 0 plus 3. That equals 1 plus 3, which means it's 4. And I want you to notice this pattern. I'm going to use red. Can you see that when here it is 1, now it jumped up 3 units because of this 3. So I don't need, I mean, I'm going to do it, you know. I'm going to do it. G of 1 is 2 raised to the power of 1 plus 3. This is a 5. And you knew it, because if this were of 2, then you just do 3 more, and that's a 5. Then it's just 3 more right here, which is a 7. And if you get a 3, then this is going to be an 11. Are you getting this? Can you see that the y values were increased by 3 because of this plus 3? It means that all these values, which are I'm now going to doing, are going to be up by 3. So if we started here 1, 2, and 3 more, here 1, 2, and 3 more, this one 1, 2, and 3 more, and so on, 1, 2, and 3 more, somewhere over here. And let's do it in blue again, but now this is not going to touch this invisible line, which I'm going to do in red. This one, can you see? It means that this graph, g of x, will never touch 3, and now f of x will never touch 0. That's what we wanted to see. Now you look at the y-intercept. Whereas this one is 4, sorry for all this mess. This one is 4, this one is 1. So we pulled it up by 3 units. The domain, remember my secret? The domain doesn't change. The domain is all reals for both. Because the ones that we're doing this in this unit are all the same, you know, in terms of domain. But now if we talk about range, now we're having a different story. Can you see that f of x, it starts in its lowest value, which was 0, and then going to infinity and beyond. Whereas this other one started at, yeah, you're right, 3. So for f of x, the range of f of x was from 0 to infinity. And for g of x, its range, can you see that it started at 3 and then it goes to infinity and beyond. Hey guys, that was it. Now you can start doing your homework. Have a good one. And I'll stop this.